So let's start today by reviewing the word angle. By definition, an angle is what occurs when two rays share a common endpoint. So if you recall, a ray is a part of a line that starts at a point and goes in one direction. So this is a ray, and so is this. And they have arrows on the ends that continue forever in one direction. So now the way that we label angles is that we have a point on each ray, and we have a point where they come together. This point where they come together has a word, a name, and that is vertex. So point B is the vertex of this angle. We name angles two different ways. We use a little angle symbol that looks like this, and then we label them in letter order where the vertex is always the middle point. So we could label this angle A, B, C. We could also label it angle C, B, A. What's important is that B, the vertex point, is always the middle letter. And then sometimes we could even just call this angle B, which is the vertex itself. So you probably also recall that there are different types of angles. When we have two rays that form a 90-degree angle, this is called a right angle, or a right angle. And we'll talk about how we know that's a 90-degree angle in a few minutes. So this part inside between the two rays is called the interior of the angle. And that is what we measure. We measure the interior of an angle. Okay? So when the interior of the angle is smaller than a right angle, we call that an acute angle. And when the interior, the inside of an angle, is larger than a right angle, such as this one, we call that an obtuse angle. Now there's a couple of other angles that you haven't heard yet, but I'll just go ahead and tell you. If you draw an angle where the two rays go in opposite directions, looks a lot like a line, doesn't it? We call this a straight angle. And I think that's pretty obvious why it's called a straight angle. There's also one other that definitely is not something we usually talk about in fourth grade. But what if you had an angle that was greater than a straight angle? Well, you might think that's just a regular obtuse angle. But say the interior is this side of the angle, not this side. We call that a reflex angle. That's something you don't really need to know now, but just a little bit of extra information for you. So we can measure angles, and the unit of measure that we use when we talk about angles is degrees. Now we don't write the word out, we use the symbols. So say an angle measures 90 degrees, we use like a little circle that's raised like that. That means degrees. The tool with which we use to measure angles is called a protractor. And now we're going to talk about how to use a protractor. So the first thing I'd like you to do is look really closely at your protractor and see what you notice. Well, you might notice that there are a lot of marks and a lot of numbers on this protractor. And sometimes people use protractors incorrectly, but not you guys. You are going to use them correctly. So, first thing you need to notice that at the bottom here, there's like a ruler included in this protractor, which is a really great thing to have. You can see the protractor on the bottom measures up to 4 inches. And then on the inside, these would be centimeters, with the small piece inside of them are called millimeters. That is a metric unit of measure versus inches, which are considered customary. We'll talk about that on another day. So on the circle part of your protractor, we have the degrees marked off. And the units that you can see is that every 10 degrees contains a number, right? And there are 10 parts within between each number. So each of those little marks represents 1 degree. Now, you may notice on the outside, the numbers start on the left and go from 0 all the way around to 180 degrees. Although it doesn't say 180, you can see 170. 10 more would make it 180. That makes sense, right? We start the left, we go around to the right. Now, on the inside, however, though, you'll see that the same 10, every 10 degrees is marked, but it starts on the right and goes backwards to the left. And I'll explain why that is in a moment. But right now, I just need you to see there are two different scales. There's the upper scale and there's the lower scale. Okay? Another important part of this protractor is this intersection right here. You see there's a horizontal line and a small vertical line that come together to form a point. That point is super important and really critical if you want to measure your angles correctly. This is where you're going to line up your vertex of your angles. And I'm going to show you how to do that in 1 second. Okay, so I've given you a worksheet that has angles drawn on it, and we're going to measure these angles. But first thing I want you to do, a little trick that I've learned over the years, is I would like you to take a highlighter or a Sharpie or a marker or something, and using the straight edge of your protractor, I would like you to make the rays of your angle longer. And the reason for this is sometimes they're too short. These are pretty good, but they'll be a little bit easier to read if they're longer. So I'm going to line up the straight edge along one side of my angle. We're going to start with angle A, and I'm just going to trace it all the way, okay? It'll make it a little easier to see when I'm reading it on the protractor. I'm going to do the same thing to the other side. So although I've made the sides or the rays of the angle longer, I have not affected the amount of space in between them. Okay? So now, remember how I told you the most critical piece of the protractor is where you see that intersection at the bottom between the two rulers? That needs to line up exactly on the vertex. Now, what it means is that horizontal line there needs to line up on one side of your one of the rays. So I want the vertex to be where those two lines intersect, and I want the straight line that's going horizontally to be lined up with this ray. Now I could also do it the other way if I wanted to. I could turn it this way and line up this side of the ray, but I'm going to do it this way for right now. Okay, so position it like that, and then let's talk about how to read it. All right, now because we made the ray longer and it's in a color, it's more obvious what the reading is. You can see now we are looking at the outside scale because we started at 0 and we're reading an angle that opens up to the left. So we're going to use the upper scale. And you can see pretty much the line is going through 70. So I would call this a 70-degree angle. Okay? Now, let's try measuring it the other way. So I want you to turn your paper and line it up again, but this time the vertex still goes in the same place, but this horizontal line is going to be lined up with this side of the ray, or this side of the angle. Okay, once you get that through, I want you to notice where the line goes. Now this time, if you look at the outside angle, it shows it's 110, but we don't need the outside scale. We now need the inside scale, and that's because our angle is opening up to the right. So we're going to use the inside scale. And if you look, what's below the 110 is 70 degrees. Same reading, just because we used a different scale because of the direction the angle opened. All right, so right now I'd like you to just jot a note at the top of this piece of paper to help you as you're measuring. A reminder that if your angle opens to the left, use the upper scale. If it opens to the right, use the lower scale. Okay? Then I want you to go ahead and highlight all the rays and measure your angles. Pause the video and then come back and see how you did. All right, so here are my measurements. How close were you? Okay, so if you now think about the measurements that you just took, we know by definition a right angle is equal to 90 degrees. So now we also know that an acute angle is smaller than a right angle. So we can say it is less than 90 degrees. That makes an obtuse angle greater than 90 degrees. Now, we're going to talk a little bit more about that though, because a straight angle, if you remember, I told you is what happens when two rays go in opposite directions. Looks like a line. That is a 180 degree measurement. So if an obtuse angle is greater than a right angle, it's also less than a straight angle. Okay? So an obtuse angle is greater than 90 degrees, but it's also less than 180 degrees. And then I told you about reflex angles were greater than a straight angle, so it means they are greater than 180 degrees. So make sure you include all of this in your geometry journal notes, and I'm going to give you some practice to measure some angles and practice drawing angles also. So hope you enjoyed this. Talk to you later. Bye-bye.